Chapter 7, Chemical Quantities and Reactions. In this chapter, in this section, you need to get your calculator out and do these problems that we're going to be doing. Now, the key to all of it is in section 7.1, the mole. And so let's try to visualize what the mole is. It's not like the thing on a witch's nose, or it's not a little black furry animal. In chemistry, a mole is an exact amount of particles. To show a decent analogy, think of a dozen. Now, if you thought of a dozen eggs, you knew it was 12. Great. So if you have a ream of paper, it's 500 sheets. If you have a case of sodas, that's going to be 24 cans. Well, because atoms or molecules are so small, then the unit that we're going to use has to be really big to have a big enough unit for us to be able to measure. So rather than calling it a dozen, which would be 12, or a ream, which would be 500, the mole's value is 6.02 times 10 to the 23rd. So I'm assuming you know that's a really big number. Now, in this section, our learning goal is to use Avogadro's number to determine the number of particles in a given number of moles, and vice versa. So, small particles, like atoms, molecules, and ions, are counted using the mole, a unit called Avogadro's number. So, Avogadro's number is 6.02 times 10 to the 23rd items. And you go, what do you mean items? Well, we're using it as atoms or molecules. You could have it as sumo wrestlers or cars or planets. It's just the number. Just like a dozen eggs is 12, I could also have a dozen boats, and we would know what that is. Or a dozen shoes. Anyway, the point is a mole is 6.02 times 10 to the 23rd. So if you notice, this is a really big number in case you didn't already know that it's a really big number. And so Avogadro's number is named after the famous Italian physicist. Now, so then, let's see. A mole of an element is 6.02 times 10 to the 23rd atoms of that element. A mole of carbon is 6.02 times 10 to the 23rd atoms of carbon. A mole of sodium is 6.02 times 10 to the 23rd atoms of sodium. In table 7.1, it gives us more examples. Let's look here. A mole of water is 6.02 times 10 to the 23rd molecules of water. Now, the reason why they're using molecules of water, not atoms of water, is because water here is a molecule. So we're not going to use the word atoms. We'll use the word molecules. So a mole of vitamin C, which is C6H8O6, is 6.02 times 10 to the 23rd molecules of vitamin C. And a mole of sodium chloride, which is an ionic compound, they call that formula units, but 6.02 times 10 to the 23rd, the formula units of NaCl. And that's the only time you're going to hear that word, but I just wanted to tell you that when you're pointing it out. We could call it, in this class, I'd be okay if you called it molecules of NaCl. It's just that that's not technically all the way perfectly correct. So let's see how we're going to use that. Since we have this equality that 1 mole is 6.02 times 10 to the 23rd particles, when we're using it in our conversion, we can say that 1 mole over 6.02 times 10 to the 23rd particles, whether it would be atoms or molecules, but we could also have inverted it the other way, 6.02 times 10 to the 23rd particles over 1 mole. So I'm hoping you can get to see what the next step is going to be, is we're going to use this in our dimensional analysis, which is we got to figure out which label is going to cancel out in order to know which conversion factor to use. So here we go. Avogadro's number is used to convert moles of a substance to particles. Here we go. How many CO2 molecules are in 0.5 moles of CO2? So let's see. We need to analyze the problem. We are given this value. This is what the number they're giving us. They want to know molecules, and the way to get from here to here is through Avogadro's number. So then we got to figure out which of the setups of Avogadro's number are we going to use. Well, let's see. We start with what's given, 0.5 moles of CO2. So that means the label mole of CO2 has to be on the bottom. That puts the 6.02 times 10 to the 23rd molecules of CO2 on top. So when we do the math, 0.5 times 6.02 times 10 to the 23rd, we get 3.01 times 10 to the 23rd molecules of CO2. Make sure you get that with your calculator as you're doing your math. If you don't, send me a message and let me help you work your calculator. Now then, what's the number of moles, what's the number of atoms in 2 moles of aluminium? Well, let's think about this. We have to get to moles to atoms, and we're going to use Avogadro's numbers. The only way to do that. But the question is, are we going to use the conversion of 1 mole is 6.02 times 10 to the 23rd atoms with the mole on top or with the mole on bottom? Well, we start with what's given, the number that's given, which is 2.0 moles of aluminium. So we know that this moles of aluminium must be on the bottom. So that puts us 6.02 times 10 to the 23rd atoms of aluminium on top. The moles of aluminium cancel out. When you do that math, you get 1.2 times 10 to the 24 atoms of aluminium. Now then, for our last problem, what's the number of moles of sulfur in 1.8 times 10 to the 24th atoms of sulfur? Now notice, this is asking the reverse of what we just did in the last problem. So I want you to notice the one difference in setting up the problem. Well, we are given these many atoms, and they're asking for the amount of moles, and the way to get from atoms to moles, or moles to atoms, either way, is through Avogadro's number. Well, let's see our choices of how we're going to use Avogadro's number. Do we have our 1 mole of sulfur on top, or do we have the 1 mole of sulfur on bottom? Well, let's set up our problem. Let's start with what's given. Let's write it down. 1.8 times 10 to the 24th atoms of sulfur. Well, once we write this down, it's straightforward. Oh, I need the atoms to cancel out. So 6.02 times 10 to the 23rd atoms of sulfur is on the bottom, so that the atoms of sulfur cancel out. We have the 1 mole on top. So your problem ends up being 1.8 times 10 to the 24th times 1 divided by 6.02 times 10 to the 23rd. And your answer is 3 moles of sulfur. Now please do this on your calculator and make sure you get 3. If not, you're doing just one little thing wrong on your calculator. You're using times, and then your 10, and then you're doing something rather than your EE button or your EXP button. So please send me a message if you can't get this answer. Please also watch the videos that I have links to give you more examples of this.